Hello everyone. So I hope you all are doing great. So today we will be looking into one of the sorting algorithms that is called bubble sort. This is one of the simplest algorithm that has been used to sort an array. So let's look into the definition of this. So bubble sort is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in the wrong order. This algorithm is not suitable for large data sets as its average and worst case time complexity is quite high. So this is just repeated swapping of elements based upon their values. So let's start with an example. We have an array with values -2, 45, 0, 11 and -9. So let's try to apply the same concept of repeated swapping the elements. Let's start with the beginning. We have two elements, -2 and 45. We know that 45 is greater than -2, so they are in the correct increasing order. So we are not going to swap them. If we go to the next step, 45 and 0, we see that 45 is greater than 0 and they are in the wrong order, in the decreasing order, but we need to have in them in increasing order. So we will be swapping them. In the next step, again, we see that 45 is still greater than the element next to it, that is 11. So we are going to swap them again. Again, at the last, we are seeing that 45 is still greater than the last element. So we swap again and we get the greatest element at last. So as we see that we are repeated swapping the elements, so we will keep doing this again and again until our array gets the sorted array. So let's again apply the same algorithm. We have 45 at the last. We'll start from the beginning, -2 and 0. These are in the same correct order, increasing order. So we don't swap them. Going further, 0 and 11. Both are in correct order. So we don't swap them. Now we move forward to 11 and -9. We swap them and they become -9 and 11. So we see that our another element came at its correct position. So let's swap elements again from the start. We have -2, 0 in the correct order. Then we have 0 and -9, which are in the wrong order. So we are going to swap them. Then we have 0 and 11, which is in the correct order. So we again got another element in its correct position. So let's again repeat this process. And we see that by repeating this same process, we got our sorted array, -9, -2, 0, 11, and 45. Now let's look into the approach or the code base, how we are going to apply that. So we have a function bubble sort, which takes argument as array and the size of array, that is n. We will be using loops here. So this outer loop will be helping us to reinitiate our swapping process for each element again and again until our array becomes sorted. So we have another loop inside that, which is helping us to swap the elements if the element where we are currently and the element which is next to it, they have a difference in the value. If array of j, the current value, and its next value, if the current value is greater than the next value, we need to swap them. So we are using some algorithm here to swap them among themselves. And at the last, we are going to return the same array that has been under the swapping process. So now let's look into the complexity analysis of the same problem. We see that we are applying two loops. So I hope you are familiar with complexity, and we know for a particular loop to run execute the same operation for the whole array, it takes O of n. But if we are applying that same loop on each element every n times, that means we are doing n square of processes or repetitions. So we have here for each loop the time complexity for a particular loop, that is O of n, and for the inner one, that is O of 1, O of n, and for particular operation like creating a variable and interchanging the variable values, and again changing the value, those are of 1 time complexity. So at the last, due to using two loops and performing same operation on a particular element multiple times, so that gives us the time complexity as O of n square. Now let's look into the space complexity. That is, I think you guessed it right. As we are not using any particular extra space or any particular data structure like array or object to store our values, so the space complexity remains as O of 1. So I think you got the idea how this works. Thanks for listening to the approach that I have shared. Have a great day.